All right, good morning, everyone. Good morning. Can we please talk about how we let the computer take out some sticks from the variable sticks for homework 4? Sure. I actually sent you an email about this about 20 minutes ago. But let's talk about homework 4 in general, because that's due tomorrow morning.
It's homework for. I talk about homework for, not homework free. It's my mistake. Nick.
Yeah, homework 4, right?
Yeah.
Yeah. That's what we're talking about.
So, yeah.
Um, yeah. So one general comment. So let's tag this. So one general comment about coding, and this is maybe especially true in C. Um, Use good variable names. Okay, it takes a little more typing, but um, but that's part of coding, right? Um, and using a variable name like total number of sticks or number of sticks to take is more meaningful usually than using I and J, or N and S, right? So and I don't always do that when I'm writing sample code here, but when you're writing code in an editor, be generous with your variable names, right? When I learned to code, your variable names were like one letter or a letter followed by a number, right? True story, Fortran. Um, and that was all the compilers could handle. So I was really excited when I got to C and I could actually use like descriptive names for variables. So number of sticks, right, might be the total number of sticks in the pile. So when you parse your first input, your command line argument or the response to the question, how many sticks do you want to play with, load that into a variable called number of sticks, right? And in your scanf, you can just, scanf string, comma, %d, comma, ampersand number of sticks, right? And then when you ask the user how many sticks do they want to take, load that into something like, number to take, or number of sticks to take. Um, and then, validate that this is a number between 1 and 4. Check the return code from scanf to make sure they didn't type in something that wasn't an integer. And then when you're done with all of that, how do you adjust the number of sticks, right? Just number of sticks equals number of sticks minus number to take, right? And in your code, assuming you type better than I write right now, this is pretty clear. The number of sticks is the original number of sticks minus the number that was taken. And if number of sticks is less than or equal to 0, well, that means the game is over. And now you write your logic for what you do when the game is over. And so on, right? When it's the computer's turn and you want to decide how many sticks to take, number to take equals number of sticks modulo 5. And we have this extra rule: if the computer tries to take 0 sticks, that would be an illegal move. So if number to take is 0, set it to 1. And then whichever you ended up with, whatever the total number of sticks is to take, subtract that from the number of sticks. All right, and do these things in pieces. Write something that just asks the user how many sticks to take, subtracts it from the pile. Ask how many sticks to take, subtract it from the pile, and print out the pile size, after each of of those operations, and that lets you work on this, right, without worrying about all the rest of the code and modulo and error conditions and all that kind of stuff. And then, maybe add in your print stick routine so that after you take some sticks off, it prints out, the pile of sticks with the number of sticks in parentheses. And then maybe once you got that working, go ahead and put in your error checking code. So if the person says, I want to take, 1,000 sticks, it says, sorry, that's not a valid number, right? Build this up. Don't write your whole program and then try to compile it and run it for the first time. Build it up in pieces. So that as you're approaching the finished product, right, it's continuing to make sense along the way. Let's see. So for homework 4, we should convert strings to numbers, right? Yeah. So anytime that you're going to do arithmetic like this, you got to have integers. So number of sticks to play with, number of sticks the person wants to take, those have to be integers. That's where you're going to use scanf. Okay. In general, we only want scanf if we need to convert a string to an integer. And when we ask the user for input, we're using fgets to read in what they're typing, and that's going to load their keystrokes into a string basically, and then we use scanf to convert that to an integer. Since we're talking about variable names, let me just mention something here that we usually pick up from context, but I don't know if it's actually talked about. But there's sort of two conventions for naming variables. So, if I call a variable total number of sticks in pile, right? That's a little hard on the eyes to read and know what's going on. So there's sort of two conventions that we see mostly. The old school way of writing this would be to use underscores to separate things out. We don't usually want variables to have spaces in their names. So we might say total number of sticks in pile. Okay, that's something called snake case. Because someone thought that's what snakes look like, I guess. Someone from the city. The other way that we do this is what's called camel case. In camel case, you basically uppercase the first letter of each word in your name, but usually we don't uppercase the very first letter. So this would be something like total number of sticks in pile. And that's camel case. Because someone thinks that looks like a camel. People seem to prefer camel case. I mean, I grew up doing this because early languages compilers didn't pay attention to uppercase, lowercase differences. So you had to do something like this. Well, it doesn't matter if it sees differences, but this seems to be the preferred way to do things now. That's what you expect to see if you're a Java programmer. That's what you're expected to use in general. But personal preference. And if this really works for you, I'm okay with that. When you're doing team programming, somebody might say something about it, but I'm fine with that. So whatever makes sense. But this is better than this is the number of sticks and this is the number that I want to take. That's going to get you confused. Maybe not in homework 4, but in some of the later assignments we're doing, we're gonna have a lot of variables, and so get into that habit, right? And variable namespace is cheap and doesn't affect the size of your final code either. It all gets reduced down. All right, other questions? So let's look at the previous ODP, and some comments I've been making to people, more than a few people, and so let me make them here in general. The ODPs are numerically a small part of your grade, right? But understanding what you need to understand to do the ODPs, that's the whole difference between being successful in this course and not. If you can do the ODPs, if you really understand them, if you could come back, a week later and knock off this code in, a few minutes, you're in really good shape, okay? You're getting the fundamentals, and we're just going to keep building on those. If you get to the exam and you still don't know how to do the ODPs, the exam is going to be hard, okay? Midterm and final. So even though, the ODPs close at 8 in the morning, if you didn't figure out how to do it, or you got full points, but you're not quite sure why what you did worked, right? You need to figure that out. We can do a little bit of that in email, but far better is to come to office hours, right? I have office hours Monday, Wednesday, Friday. Come in, show me your code, tell me what you're trying to do, run your test cases, let's see what's happening. I can point you in directions that will help you figure things out, okay? That is absolutely the best way to approach these ODPs. And like I say, even if it's already done and turned in and you can't get a grade on it for resubmitting, right, you still want to figure these things out because they're important. So let's look at ODP 413. So this was a function that would count the occurrences of the letter E inside a string. And the string is passed as an argument. And then you write a loop in here that iterates over the characters in that string, adds to a running counter, and then returns the value of that count. All right. So let's take a look at what that looks like. But first, gotta have our earthquake drill.
Right now, drop, cover, and hold on.
All right, so this is an earthquake drill,
This is not a real earthquake.
and it might feel silly, but drop cover and take hold until this ends.
Hold on to it until the shaking stops. If you cannot get under sturdy furniture, protect your head and neck with your arms. If you are indoors, stay indoors. If you are outdoors, stay outdoors. Injuries are more likely when you try to move around. This is an earthquake drill. If you're in a high-rise or public building, drop, cover, and hold on. Do not use elevators. If you're outdoors, move to a clear area away from wires, buildings, and anything else that could fall and hurt you, but only if you can safely do so. Drop, cover, and hold on. If you're in a stadium or theater, drop, cover, and hold on. Protect your head and neck with your arms. Don't try to leave until the shaking is over. If you're in bed, stay there and hold on. Protect your head with a pillow. If you're driving, don't do anything now. During an actual earthquake, you should coast over to the side of the road. Stop and set the parking brake. Avoid bridges and overhead hazards. Stay inside the vehicle until the shaking is over. The main shock is now over. This concludes our earthquake drill.
All right, we made it. All right. Yeah, so that's the Great American Shakeout. And normally at Clark they do this, and you drop down under the tables and you discover how much gum people still put underneath tables. I'm kind of doomed in my apartment because my desk and my drafting table are glass tops, so not a lot of protection there. Anybody here ever been in an earthquake? Yeah, lots of people. I used to live in San Francisco, and you'd feel small earthquakes. The only time I ever felt a big earthquake was actually in Northern Virginia, and it was so weird because you don't think about earthquakes in Virginia. So, of course, my friend and I did all the wrong things, like going outside to see what was going on immediately and stuff like that. So yeah, lots of earthquake experience here, it seems. So it's good just to kind of think about, and you know, I hate to say it, but 2020 doesn't seem to be a really friendly year so far. So it's good to be up on these kinds of things. We get worn down by one thing after another, and so it's good just kind of in the back of your mind to refresh these things once in a while, lockdown drills and earthquakes drills and things like that. We've never been in any kind of natural disaster. That's good. I knocked wood for you. All right, so so back to ODPs. So let's take a look at some of this code. So again, it's not that the challenge here is that there's so much code to write, right? The challenge is in some ways that there's so little code to write, but that code has to be just so, right? So so here's my count function. Now I included string.h because I plan to use the string length function. You don't need to include stdio.h unless you're planning to use printf, fgets, scanf, things like that. Things that are related to typically doing input and output, right? If you need stdio.h and you don't include it, you'll get warnings. If you don't need it and you include it anyway, it doesn't really do any harm. It takes a little bit of extra time to compile, but it doesn't really hurt anything. But it's nice to know when you have to include it and when you don't. So I'm not doing any input-output here, so I don't need standard I/O, but I am using string length, so I need string.h. Now if I was looping to pick up the null terminator at the end, I would not need string.h, so I wouldn't have to do any includes. And hold on a second. All right, cool. All right, so the function prototype was given in the README, right? But when you actually declare the function, you have to specify a variable name for the argument so that you can talk about the argument inside the code. So it doesn't matter what you call the argument, right? I called it arg for argument, but you can call it anything you want. Doesn't matter if it's the same name as what you're going to use in the main program when you call this function. It's just a local variable. Okay, and the value of this variable arg has no impact on anything outside of this function. So initialize a counter, and you always have to initialize variables in C. Now on some machines, integers get initialized to 0 for you, but that's not standard, right? And it can get you in a lot of trouble if you get in the habit of sort of doing this lazy initialization where you just let the compiler set your variable to 0, and then somebody tries to compile your code on a different machine, and suddenly it's blowing up 100 different ways. So initialize your variables, okay? Java, the compiler will actually warn you if you don't initialize, and it will refuse to compile. So this is always a good habit. So C is my running count. Could have named it something better than that. And then the for loop we talked about yesterday was going from index 0 through string length -1. And for each of those, compare the character at position I with the character E. And if they're equal, increment C. So plus plus C is a shorthand way of saying C equals C plus 1. And I'm indenting my code not because it gets me points, but because it lets me see better what's going on. So here's something that I've seen some people do. So I've seen people write code like this, right? The compiler doesn't care how you space your code. Makes no difference. But to you and me trying to read this, the indenting will help. Okay. And this code, you know, at first glance looks reasonable. There's my for loop, and if the character is equal to E, I'm going to increment my counter, and then I'm going to return the count at the end, right? But this code will not work. There's a fundamental problem in here. And if you indent your code, so I like to indent everything in my code, everything inside a function, so that the only things I have in column 1 are, you know, outside of my function, or the declaration of a function, or the end of a function, or maybe my comments. And then for loops, I like to indent those. And then if statements, I like to indent the body of my if statement. And if I do that, it's a little clearer now what the problem is with this code. Right? And if you're using you know, syntax highlighting and stuff like that, this will jump out to you even more. But this is my for loop. It starts here, it ends here. I'm using the % sign in VI, by the way, to match and jump to matching curly brackets. So there's my for loop, right? And my return statement is what? It's inside my for loop. So I start my for loop, I is 0. If character 0 is E, I increment C, and then I return. And I'm returning either a 0 or a 1. I'm only checking one character, right? And this is really obvious just from looking at, you know, how things are lined up. So what I really wanted was this, right? And here I can see, you know, what's the main body of my code. It's a declaration of an integer. It's a for loop followed by a return statement. Right, so it's three things: initialization, processing, and exit. All right, so the logic of the code is not that sophisticated, right? It's a for loop, a comparison, and a running counter. But getting that nailed down just right, can be tricky. All right, so I'm not going to do any more ODPs for the rest of the week. We'll start them in again next Monday, but we'll take a break from that. So let's talk about the online quiz. Which I guess I have to pull up Canvas for. Alright, just bear with me 1 second. Alright, so this was the online quiz that most people finished. So the first program was basically saying enter an integer, doing a scanf, and then printing out success. And I asked you to run this by entering the word hello. And what you probably found it does is it prints out success, I equals 0. Okay, and the person did not type in the word, the string 0, they typed in a word hello, which is not the same as 0. So your code ideally would detect that hello is not a valid input, right, if you were expecting an integer. But scanf, the way I'm using it right here, will not tell me that, right? All that I'm doing is I'm calling scanf, I'm passing it the input string, and I'm passing it a variable to save the converted value in if it converts a value. Well, it didn't convert a value, and so I has the same value that it had before the call, which was 0. But my code has no way of knowing that, right? I just call scanf, and then I say, congratulations, you entered an integer. Okay, so that's clearly not something that we want, right? If we care about, you know, the integrity of the user's input, we need a way to know what they typed in. So here's a better approach, right? where we actually look at the return value from scanf and we make sure it's a 1 to see if they did in fact type in a valid integer. Alright, so if I run this and they type in 23, it says success. That works great. But if you run this and you type in something like hello, you've almost got the black hole eating up the galaxy, right? So Control C gets you out of that. But what happened? I did my scanf and I said I would like to read an integer and save it in the variable I. And scanf looked at my input and it said, nope, that's not an integer. And it returned a 0. That's good. And my code detected that 0 or that non-1 value and said, that's a problem, please try again. And it prompted me again. That's good. And then I went back to scanf. Well, what did scanf do? It looked at my input buffer and it saw hello. And it said, nope, that's not an integer. It returned a 0. My code said, please try again. Go back up here. Scanf looked at my input buffer and it still saw the word hello and said, nope, that's not an integer, right? And I'm stuck in an infinite loop. And there's no way I'm ever going to get past that word hello in my input buffer because my scanf is not ingesting the letter H because it doesn't correspond to part of an integer. Okay? This is a problem with using scanf. So scanf can get stuck unless you then go ahead and you do something like scan off a character or scan off a bunch of characters until you get to a new line or whatever your terminator happens to be on this operating system, and so on and so forth. So this is a classic problem for which I say don't use scanf. Okay, so so question 2 works fine with a number. Question 3 goes into an infinite loop. So here's a version of the code where we've actually split up the input and the parsing into 2 separate steps. So enter an integer and we use fgets to get that integer, to get that string, and then we try to convert that. And if that conversion fails, we prompt the user again, but we call fgets to let them put in a new line of input. And then after they put that in, we'll come back up here and we'll try parsing that, and so on. Right, so here if I say hello, it will go back and it will say try again. And I'm in my call to fgets. So it's waiting for me to type something. Right, so that's the preferred way for now to handle input where there might be errors in the input values. All right, so that was just an exercise for that. So any questions about that? All right, let's see. 413. Final questions on the stick program. Looks like people are either done with that or they're getting really close, which is awesome. Do we have office hours? No, next office hours are Friday at 2 o'clock. But if you have questions, you can ask them right now. Alright, so having problems scanning in a character variable for parse. Let's play with this. Alright, right. So let's just play with scan, okay? scanf, and let me give you something. Not a hard and fast rule, but a general guideline. Usually, and particularly in this course, scanf is going to be used to convert a string, like, you know, double quote 1, 2, 3, to a plain old int. So by a string, I mean an array of characters. I mean an array containing ASCII code 49, followed by ASCII code 50, followed by ASCII code 51. And if we try to, you know, take this and compare it to the number 4 to see if this is bigger, it's not going to do what we think, right? This thing, quote 1, 2, 3, is actually a memory address, right? And even if we looked at what was stored at that memory address, the first thing we'd find is the number 49, right? And if we treated this contents as an integer, it would be some huge gargantuan number, right? So this is not at all what we mean when we say, is this thing bigger than 4? So we need to convert this to the actual number 123, right? So 64 plus 32 plus some change at the end. So a integer containing mostly zeros and then a few ones towards the least significant side. So that conversion, that's what scanf does, right? And how does it do it? It looks at this character and it subtracts 48 from it, and it says, oh, this is the digit 1, and then it multiplies by 10, and then it takes this character, which is 50, and it subtracts 48 and gets 2, so it adds that and it gets 12, and then it multiplies that by 10 to get 120, and it takes this character, which is 51, and it subtracts 48 to get 3, and it adds that, and it ends up with 123. Right? That's what you're avoiding having to do by calling scanf. Okay? But for most of what we do in this course, and for you know, the ODPs we've done, and for the stick program, that's all you're going to use scanf for. In particular, if you have a string and you want to do something with a string, do something with the string. You don't need to use scanf to process a string that you want to treat as a string. And in particular, using scanf with a %s usually makes no sense. Right? If I have a string and I try to scan it with %s into another string, I'm not really doing a whole lot, right? And %s does some extra things. It chops things up at spaces and so on and so forth. So use this if you have an integer stored as a string and you want it to be a plain int. Other than that, stay away from scanf. Okay, it's useful for parsing, interpreting a string differently, but other than that, you don't need it. If you have a string, use the string. So let's just play with this. So let me do this. So I'm going to initialize str. I'm going to say it's a pointer to a character, and I'm going to give it a value in the declaration of it, like this. If this doesn't make sense to you, don't worry about it, but I'm just saving myself from having to do an fgets and type in 1, 2, 3. So I'm setting str to be the string 1, 2, 3, and let's scan it. right? And let's just print out the value of I before and after the call to scanf. And let's give I some interesting value. I think I forgot a semicolon. Question understatement line 9. Forgot a curly bracket. Alright, so before calling scanf, I is equal to 42. After calling scanf, I is equal to 123. Right? So this is how we call scanf, right? String containing the characters you want to interpret. A specification of how we want to interpret it, and %d means treat it as an integer. And then the address of the variable we want to save the converted value in. And we'll talk a lot more about percents in the future and ampersands in the future. But this is saying I want to give scanf the address of the variable I, so that scanf can load something into the variable I. And for now, you can just take that as something we always do when we have a %d. So if I have a string that can't be converted, right, then the value of I before scanf is 42. The value after scanf is still 42. All right. So if I don't do anything else, I'm going to assume the person typed in the number 42, or that my string was equal to the string 42. So we need to know that the conversion failed. That's what we use the return value for. So let's print out the value of R. So in this case, the return value from scanf was 0. In the earlier case where we had a number that was successfully converted, the return value is a 1. This is the thing that tells us that the value of I is meaningful, right? If we see a 0 from scanf, don't assume that I corresponds to the string that you tried to convert. It doesn't. But if the return value from scanf is 1, then we know that the value of I corresponds to the string that was converted. So that's why we always need to look at the value coming back from scanf first. Alright, so if that didn't answer the question about scanning, send me an email after class and we can talk about it through there. Let's go on with chat. I'm having problems scanning, having trouble looping through mistakes and with decimal numbers. We'll come back to that. Okay, one was 31 hex, 49 decimal. Good job on clarifying that. Let's see. Do you mean scanf or scanf? Because scanf should not be used, and scanf does not take input, right? fgets takes input, and then scanf converts that input, right? But if you're trying to read from the user who's running the program, don't use scanf, use fgets. Okay, read in the line and then convert it using scanf. Someone caught my missing curly bracket, good. Are we still required to have the pipe loop for the number of sticks? Yes, people keep asking this. ODP, homework 4 is exactly like homework 3 except for the differences listed in the beginning. So same gameplay, same strategy for winning, same output requirement after each turn. Show the pile of sticks as a set of pipes with a parentheses with the number of sticks listed after it. So all of that is still the same. All right, good. Keep going. We got time left. And when we're done with this, I'm just going to go back to talking about VI. So I would rather talk about things topical to homework 4. while we have time here. No more questions. Do we push the executable to GitLab too? Yeah, go ahead and do that. I'm going to recompile your code anyway, and yeah, you definitely need to push all the files I need to compile it, because my plan is to compile your code and go ahead and execute it. But if for some reason I can't compile your code, right? I can try your executable, but I can't grade your assignment based on the executable. Okay. I noticed that in your stick program, you print out the number of sticks right after you ask how many to play with. Yeah, show the stick pile every single time, including in the beginning. I think the README says that. I mean, I'm not going to knock you down 60 points if you don't do that. But yeah, always show the stick pile. Initial pile, and every time it changes. Let's see. On all the files. Yeah, so if you've got multiple files, don't forget any of your files. If you wrote a .h file, don't forget the .h file. How to show the sticks, pipe after the user enter numbers in C. So write a for loop to show the stick pile. If you know that you want number of sticks, right? So you can do for integer I equals 0, I less than number of sticks left, I plus plus, right? So printf doesn't put a new line at the end automatically, so this will print out number of sticks left pipes, right? Edge cases, if this is equal to 5, how many times will our loop run? Well, it'll run for I equals 0, 1, 2, 3, and 4. And then when I increments to 5, it will exit. So 1, 2, 3, 4, 5 times through the loop, 5 pipes for 5 sticks. That takes some thinking about the first few times. Eventually, this will feel automatic to you. And then, you know, just print a %d in parentheses followed by a new line, number of sticks left, after your loop. And that'll print out the number in parentheses. Let's see. Yeah, because the number is nice, because I have a hard time counting the sticks. How do we make it run a function that doesn't have a return? How do I make it run a function that doesn't have a return? So I'm not sure what it is, but if your main program doesn't have a return, that's okay. I mean, you run your executable the same way. If you call a function that doesn't return a value, you can still use a return statement without a value, or you can just fall off the end. But you can say return semicolon, and as long as your function was declared to be void, saying it's not returning anything, this will get you out of the function. I don't know if that was the question or not, but that's a thing. Yeah, and declare the function to be void, as someone just said in chat. So void. Instead of saying int or float or char star or something like that. And void is not a type of variable. Void is really just kind of a keyword. It's a hook that says there's no value being returned by this function. And if you declare a function to be void, right, you can run it by just saying, you know, the name of the function with whatever arguments, semicolon, right? And if you try to do something like I equals name, that'll give you an error. Alright, so I'm trying to get my main to run the function with an input, and it's saying there's an implicit declaration. Alright, so to run the function with an input, are you talking about a command line argument? Or are you talking about user input while the program is running? So if you want to run with a command line argument, right, like that, when you write your main program, you have to do the argc. Like that. And in the logic of your main program, you would look at argc and see if it's equal to 2. And if it is, then you know that there was an argument given, and you know that argument is tucked away in argv bracket 1. And you go ahead and you take that and you run it through scanf. And if your argc was equal to 1, then you use fgets instead to read in a string saying how many sticks you want to play with. You run that string through scanf, and you go on with the game. And if this is bigger than 2, that's an error condition. Tell the person that's not valid and just give up. And this can never be 0, so that's not a case you have to check for. Implicit declaration usually means that you haven't prototyped something, or you're doing something that looks like a function call when in fact it's not. It's supposed to be a function call. But when it complains about implicit declaration, it usually means you're using a function and you haven't told it what that function expects or what it returns. So the prototyping. But yeah, definitely send me an email, and again, you know, there's notes, there's a video, there's comments about the best ways to send me code in email. People are still sending me attachments, and I have to use Outlook, and Outlook doesn't play well with attachments, and things get goofy and all this sort of stuff. So just paste your code into an email message. Most people are doing this now, which is awesome because it's really easy to look at their code and copy it and paste it in and try it and stuff like that. So, but go ahead and send me email after class if you have questions about scanning or input or anything else on this stuff. All right, we are out of time. I will see you Friday. Have a good afternoon. Thank you.